All right, so number 17. What's the big difference on 17 versus, if you take a look at yesterday's notes, like number 15 and 16, how is 17 pretty different than those? Yeah, the entire fraction is inside parentheses with the exponent on the outside there. Yesterday with 13 through 16, either the top was in parentheses or the bottom was in parentheses, or the top and the bottom were in separate sets of parentheses, taken to different exponents. So today, the first problem we see, the entire fraction is inside parentheses. And so if that is the case, this is going to be really similar. So notes for the day. This is going to be really similar to what we did using the power rule. So we still have to start with the power rule because we have stuff inside parentheses. And then from there, we're going to use the product rule that we learned yesterday. And just like if the power rule is being used only on the numerator, only on the denominator, this exponent has to go to every single thing inside the parentheses. That means everything on the numerator and everything on the denominator. So we're going to take 2 to the third power, 2 times 2 times 2, which is 8. We're going to multiply the exponents with the exponent on the outside. So m to the 4th to the 3rd, 4 times 3 would be m to the 12th power. And we have n to the 2nd to the 3rd power, so multiply n to the 6th power, all over 4 to the 3rd power, 4 times 4 times 4, which is 64. And then m to the 2 times 3 to the 6th power. And then the last one, n to the 3rd power. So it goes to every single thing on the inside of those parentheses. Now what we need to do is use the quotient rule that we learned yesterday. So we'll reduce our fraction, 8 over 64. And if you have a calculator, you're welcome to do that. Just type in the fraction 8 over 64. It'll tell you what it is. Or if you know it off the top of your head, what do you think it's going to be? 1/8, yeah. So 8 goes into 64. They both are divisible by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. However, I'm going to go ahead and write this kind of like we did yesterday. So the denominator, we're going to have an 8. And the numerator, I'm not going to put the 1 up here because we're going to have other variables when we subtract those exponents. So same variable, m and m, subtract the exponents. 12 minus 6 is m to the 6th power. And then 6 minus 3 for the n variables would be n to the 3rd power. So our answer here is m to the 6th, n to the 3rd, all over 8. That would be the result there for number 17. Now, this is one of really 2 ways that you could simplify this particular problem and get to this answer here. The other way is, if you wanted to, you could simplify this quotient here first, using the quotient rule on the inside. And if you want to simplify that fraction first, you may do that, and then you can apply the exponent afterwards. So if that's something you're interested in, it would look like this over here. So if we simplify everything on the inside here, 2/4 is the same as 1/2. M to the 4th, so it would be over 2. M to the 4th divided by m squared, you would subtract the exponent, so that would give you m squared. And then n to the 2nd over n, subtract the exponents, you'd have n to the 1st, which is just n. And so that would give you m squared n all over 2. And then you can apply that exponent to every single thing on the inside of this set of parentheses, which actually ends up getting you straight back to our answer over here. So 2 times 3 is m to the 6th, 1 times 3 is n to the 3rd, and 2 to the 3rd power is 8. So either way, you can apply that exponent first and then simplify the fraction, or you can simplify the fraction and then apply the exponent. However, I want to mention that only works if the entire fraction is inside a set of parentheses. It does not work on a problem like number 20, or actually any problem after number 19. So these first 3, you can simplify the fraction first, then apply the exponent, or exponent first and then simplify. I think in terms of ease of process, I would recommend applying the exponent first just to keep that consistent because that's what we were doing yesterday. So on number 18, if we apply our exponent first, we're going to get 12 to the second power, which is 12 times 12, which is 144. And then k to the fifth to the second, multiply the exponents to be k to the 10th, over 15 times 15. What does that equal? 225. And then k to the second power. All right. Now, we need to reduce that fraction if we can. Calculator might be the easiest way to do that. Anybody have that fraction reduced? Yeah, 16 over 25. So 16/25 is the fraction that we have there. So we're gonna have 16 on the numerator, and then subtract the exponents with the k's. So 10 minus 2 be k to the 8th over 25. So 16k to the 8th over 25. So that means that each of these numbers is divisible by 9. All right, try number 19 on your own. 19 is just like 17 and 18. Give those a try and give that one a try, and then we'll take a look at that answer in a couple minutes. Maybe even sooner than that. Yeah, I'm just going to go ahead and get attendance done here. So let's see. You're welcome. All right. All right. So, does anybody have an answer that they would like to share for number 19? Any volunteers? Alicia? 16 over 25 b squared? Yeah, that is correct. Nice. So we'll go ahead and do this first step, and then we'll get to that answer in a moment. So we've got 4 to the second power. So we apply the exponent of 2. 4 times 4 is 16. A gets raised to the second power. B to the second gets raised to the second power. So we multiply those to get b to the fourth. And then On the denominator, 5 squared is 25, and then a to the second and b to the second. That's where we're at right now. And we've gotten rid of the parentheses because we applied the exponent to everything inside the parentheses. 16 over 25, there are no common factors there, so that doesn't reduce. So the 16 over 25 stays as it is. And then why do we not have a in our final answer? Okay. They cancel each other out. Yeah, yesterday we saw that if you have two variables to the same exponent, they just cancel each other out like we would if we were solving a regular algebra equation. And we also saw that if you subtract those exponents, you get a 0. And we also learned yesterday that anything to the 0 power equals, what did we write down? It equals what? 1. So a to the second divided by a to the second is 1. And since there are other numbers alongside here and other variables, we don't actually need to write that 1. So the a squareds can just cancel out. And then we'll subtract b to the fourth, subtract the exponents from b to the fourth and b squared. 4 minus 2 gives us 2. So that would be 16 b squared over 25. Or if you had 16 over 25 times b squared, same thing, works exactly the same. So that is our answer for number 19. All right. Let's move on and start working on some of these other ones. So now we're not going to be using, at least on 20 and 21, we're not going to use the power rule at all. We're going to use the product rule and then the quotient rule. So even though we have sets of parentheses here, there's no exponents on the outside of them. So there's no power rule that we have to use on this one. So on number 20, we're going to actually multiply just everything on the top. So 9 times 4 is 36. And then with the variables that are the same, we're going to add the exponents because we have multiple of the same variable. And so that would be the product rule and not the power rule. So we add together our exponents. 5 on this x, there's 1 with that x, so that would be x to the 6th power. And then y to the 6th, and then y by itself would be y to the 7th over 6x squared, y to the 4th. Nothing changes on the denominator yet. So this is like what we did on Tuesday with the product rule on the numerator part of this problem. And now we're going to use the quotient rule. We just divide through everything. 36 divided by 6 is equal to 6. X to the 6th divided by x squared, subtract your exponent. 6 minus 2 is x to the 4th. And then 7 minus 4 gives us y to the 3rd power. We get 6x to the 4th, y to the 3rd power for number 20. So product rule, then quotient rule. All right, 21 ends up being pretty interesting because there's kind of a lot going on at the beginning of the problem, but then when you get to the end of the problem, there's not much left. So let's see what happens here. On the numerator, we multiply the coefficients. 2 times 3 is 6. Add the exponents with the same variables. 1 and 2 gives us p to the 3rd power. 1 and 4 gives us q to the 5th power. Good morning. Thank you. Oh, notes here. Yeah. Thank you. So everything on the numerator is good to go here. The denominator stays the same for now, because there wasn't anything to do there initially. So -6 p q to the 5th power on the denominator. All right. So not much of this is going to end up left. Why not? Alicia? Yeah, the q's definitely cancel each other out. They've got the same exponent, so those can cancel out. And then the +6 and the -6 divided, what does that equal? -1. Yeah, so we just end up with -1 p squared, because if we subtract the exponents, the 3 minus the 1 there, we just end up with -1 p squared. Or if you just write -p squared, that's fine too. The 1 doesn't technically have to be there. All right. you have any questions, go ahead and stop me at any point. Otherwise, we'll keep moving along here. 22. This one is going to use the power rule, the product rule, and the quotient rule. And we have to use the power rule on this one because the first set of parentheses does have an exponent on the outside of it. So this one's going to be a few steps in terms of showing what's going on here. So if we apply the power rule first, that'll give us 10 squared, which is 100. And then a squared, b squared when we apply the exponent to those. And then we can say times. By the way, this second set of parentheses doesn't have to be inside parentheses since there's no exponent on the outside of it. So we can just say times 2a to the fourth b to the third. And that's all over 4a to the fifth b. So we use the power rule first. The 2a to the fourth b to the third stays the same for now. So does the 4a to the fifth b. Now we can use the product rule by multiplying together everything on the top. So 100 times 2 is 200. Add the exponents with the same variables. A to the second, a to the fourth would be a to the sixth. And then b to the second times b to the third would be b to the fifth power. And that would be over 4a to the fifth b. Now we can use our product rule. Sorry, quotient rule. We already used the product rule. The quotient rule now, 200 divided by 4 is 50. And then a to the sixth divided by a to the fifth, subtract the exponents to be a to the first or just a. And then b to the fifth divided by b, subtract the exponents, 5 minus 1 is b to the fourth power. So 50a b to the fourth is our answer for number 22. All right. For the next two problems, 23 and 24, I want you to try those on your own. You will have to use the power rule and the product rule and the quotient rule for 23 and for 24. In fact, you'll have to use the power rule twice on both of these problems before you can use the product rule, because each set of parentheses has its own exponent on the outside. So use the power rule first, then the product rule, then the quotient rule. Work on 23 and 24. Let's go with like 3 minutes or so on that. And then if you have questions as you're going through that, please let me know. I'll come around and help if you need it. And feel free to grab a calculator if you need one. So let's have a look, see how we did on these. Number 23. We're going to use the power rule twice. So the 2x to the third to the second power turns into that 4x to the sixth power. The 3y to the fourth to the third power ends up being 27y to the 12th. Then we've got to multiply everything on the top part of our fraction there on the numerator, and then that's going to be using the product rule. So 4 times 27 is 108. X to the 6th, y to the 12th, because those are two separate variables, so we don't have to worry about adding any kind of exponents on those. The denominator stays the same for the first through those first two steps. And then we're going to divide everything through using the quotient rule. So 108 divided by 12 is 9. X to the 6th divided by x to the 4th, subtract the exponents, you get x to the second power. And then y to the 12th divided by y to the 5th power, subtract those exponents, and you get y to the 7th. So 9x squared y to the 7th power for number 23. Any questions on that? All right. For 24, it's actually really similar. We're going to use the power rule first. So the first set of parentheses, exponent of 2 applies to both of the things in there. So that would be 3 squared, which is 9. M to the second, multiply your exponents, m to the 4th. And then -4 squared, -4 times -4 is positive 16. And then n to the 5th to the 2nd, multiply your exponents, you get n to the 10th. That's our power rule step. Then we use the product rule again, so multiply everything on the numerator. 9 times 16 is 144. And again, we have two separate variables altogether, so there's no adding of exponents on the numerator. And just like the last problem, the denominator stays the same through those first two steps as well. And then the last step, you're going to take 144 divided by 8, that equals 18. M to the 4th divided by m to the 3rd, 4 minus 3, leaves us with m to the 1st, or just m. And then subtract the exponents with n as well. 10 minus 4 is n to the 6th power. Are there any questions for 23 or 24? All right. If not, we're going to go ahead and keep moving on here. By the way, we are going to do 27 and 28. I know that you can't really see those very well on your paper. I'm going to tell you what those problems actually are to begin with, so we can work through those. So here we go. Number 25. So 25, it looks like we don't have the power rule on 25 because there are no exponents on the outside of the parentheses, but we do have the product rule, and we're going to have the quotient rule. Good morning. Thank you. We got the product rule, we've got the quotient rule, and we're going to have combining like terms if possible at the end of the problem. So let's start working through this number 25 and see what we got. Start with the product rule. So multiply the things together on the top of our fraction. So 8 times -3 would be -24. And then we're going to add the exponents. C and c to the 4th would be c to the 5th. And d to the 3rd power, because that is the only variable with d on the numerator there. The denominator stays the same. 6c squared times d minus 9c to the 3rd, d to the 2nd. All right, now underneath, I'm just going to write a little bit more. I think there's going to be enough room, barely. Quotient rule next. We have to simplify this fraction. -24 divided by 6 is -4. C to the 5th divided by c to the 2nd. Subtract your exponents, that's c to the 3rd power. And then d to the 3rd divided by d would be d squared. And then minus 9c to the 3rd, d squared. So we do end up with like terms here because we have c to the 3rd d squared with both of those. This final step, though, when you combine like terms, do not change the variables or the exponents in any way whatsoever. We're not adding exponents. We're not subtracting exponents. When you're combining like terms, you're just dealing with the coefficients. So it'd be -4 minus 9, which is -13. So that's -13 c to the 3rd d squared for our answer on number 25. 26 is super similar. And the thing about a lot of these problems where we're adding and subtracting, there's a little bit of a clue as to what you should end up with for your variables and your exponents, because chances are these are going to end up being like terms. So when you use your power rule, when you use your quotient rule, chances are you're going to end up with r to the 7th s squared. It won't always be like that, but one of the main reasons why we're practicing this is because we are going to be using combining like terms quite a bit. So I wouldn't always expect it, but I would say that a lot of the time, the variables and exponents from all this stuff here are going to match the variables and exponents with whatever is being added to on the end. So let's go ahead and do our product rule here. There's no power rule on this one because there are no exponents on the outside of the parentheses. So 8 times 3 is going to be 24. R to the 5th, R to the 3rd would be R to the 8th. Add those exponents. S squared, S to the 4th. Add those exponents is S to the 6th. Over 12R S to the 4th plus 9R to the 7th S squared. And then we can do our quotient rule. Simplify this entire fraction here. 24 divided by 12 is 2. R to the 8th divided by R, 8 minus 1 gives us R to the 7th power. And S to the 6th divided by S to the 4th, subtract the exponents again, and we get S squared. And what do you know? It ends up being the same variables and same exponents as the other term over there, which means we've got like terms again. We can just add those together, only add the coefficients, do not change the variables or the exponents. 2 plus 9 is 11. So that's 11 R to the 7th S squared. And that's our answer there. Number 26. All right, the last two. Go ahead and get that down. Are there questions, by the way? Please let me know if you have questions on this. If something's not clicking or I'm moving too fast or something is just not making sense, please let me know. All right, I'll give you a little time to get that written down, and then we'll take a look at the last two problems. I'm gonna have to have you write those ones down, and we might just use the back of this paper for those last two, because I don't think there's gonna be enough room once we actually write the problems. So. We'll have a couple of secret problems on the back of this paper, unless you are gluing them in, which would not be great. Because then they'd be really secret problems and you'd never see them again. Okay. So 27 and 28. I am going to write mine on the back of my paper. If you are planning on gluing yours in, maybe just write them off onto the margin over here for 27 and 28. But I'm going to flip this over. 27. The problem for 27 is we've got 2m squared to the 3rd power times 3n to the 4th to the 3rd power over 9m to the 4th n to the 7th. And then that whole thing is subtracting 18m squared n to the 5th. 18m squared n to the 5th. All right. So this is our first problem that we've seen that is going to use every single rule that we've learned so far. It's going to use the power rule from Wednesday. It'll use the product rule from Tuesday. It's going to use the quotient rule from yesterday, and it's going to use combining like terms from Monday. So all 4 of the rules that we have learned this week are going to be in this one problem here. Same thing for number 28. That's why I really wanted to do these last 2 problems, because all 4 of the skills are being used in one problem. So here we go. Starting off here with the power rule. So we have to apply the exponents to the parentheses on the numerator first. So we've got 2 to the 3rd power, which is 8. M to the 2nd to the 3rd, multiply the exponents as m to the 6th. times 3 to the third power, which is 27. And then n to the fourth to the third, multiply the exponents, is n to the 12th power. And that is going to be all over 9m to the fourth, n to the 7th, minus that 18m squared n to the 5th. Okay. So the next thing we need to do is we need to multiply our 8 times our 27. So what is that? That's 160 plus 56. So 216. Yeah, 216. Okay. So 8 times 27, 216. And then there's nothing to add for the exponents here because they're different variables. So we've got m to the 6th, n to the 12th over 9m to the 4th, n to the 7th, minus our 18m squared n to the 5th. So power rule first, product rule second. The next step is going to condense it quite a bit because the quotient rule will make this quite a bit smaller. So we're going to have 216 divided by 9. What is 216 divided by 9? 24. All right, so 24. And I'm going to guess that we're going to end up with m to the 2nd, n to the 5th, kind of based on what we've been looking at so far. Exponent of 6, exponent of 4, subtract those. 6 minus 4 is m to the 2nd power. There's our m to the 2nd. 12 minus 7 for the n's give us n to the 5th. And what do you know? We're back with some like terms. So 24 m squared n to the 5th minus 18 m squared n to the 5th. Last step, subtract the coefficients only, leave the variables and exponents alone, keep them the same. So that'll be 6. So 6m squared n to the 5th for number 27. This is our second to last problem. We've got one more. And this last one is not going to use the product rule, actually. It's only going to use the power rule, the quotient rule, and then combining like terms. So, any questions on 27? So hopefully you're starting to see a pattern here. Clear out the exponents on the outside of the parentheses first, then multiply anything that's left over if there is anything to multiply, then simplify the fraction, and then last, you always deal with your like terms at the very end. The 28, number 28, last one here. This is going to be, in parentheses, negative 6x to the 4th, y to the 6th, and then an exponent of 2 over negative 3, x to the 3rd, y to the 5th. And that's in parentheses, and that'll also be to the 2nd power. And then minus 7x squared y squared. All right. So in this problem here, again, we're not going to use the product rule on this one, but we are going to use the power rule on the numerator and the denominator. Once we've used the power rule, got rid of those parentheses, then we can use the quotient rule to simplify the fraction. And it'll probably end up being an x squared y squared when we simplify that fraction, because that's how this stuff tends to go. And then we can combine our like terms at the end. Let's see what happens there. Apply our exponent of 2, negative 6 squared. What's negative 6 times negative 6? Yep. So it'd be multiply together. 6 times 6? 36. Yep. And then multiply the exponents here. 4 times 2 be x to the 8th. And 6 times 2, y to the 12th. over. What do we have on our denominator? Yeah. X to the, I'm going to go with X to the 6th, but Y to the 10th as well. Yeah, okay. And then Y to the 10th. All right. So 9x to the 6th, Y to the 10th. And don't forget about the subtraction. So minus 7x squared, Y squared. All right, this one's going to be a little bit quicker than 27 because we can actually just simplify this now, the fraction part of it. So what happens when we divide to simplify this fraction? What do we get? What's 36 divided by 9? 4, yep. And x to the 8th divided by x to the 6 is x to the x to the 2nd, good, subtract those exponents. Y to the 12th divided by y to the 10th is y to the 2nd again. And kind of what we expected here, same variables and exponents, which means we've got some like terms. 4x squared y squared minus 7x squared y squared. So really the only other calculation we need to do here is 4 minus 7. What is 4 minus 7 equal? Negative 3, yeah. So we end up with negative 3, so this equals negative 3x squared y squared. All right, so that is it. We're looking at a half-hour work time today, which is awesome. I'm hoping that is enough time to finish most, if not all, of the assignment.